Good afternoon, friends. So, I hope all are here. Am I audible?
Yes, sir.
Yes, sir.
Okay, okay, thank you. So, today we will see the next point from Unit 4, and that was the already we have started in last session. So, today we will continue with that. That is the DAC. So, the concept of ADC we have learned. That is how it is going to be convert the analog voltage into the digital form. So if you're taking a voltage range, for example, 0 to 5 volt, and at the output in digital format, 8 bits are there or 8 digits are there. That is 11111111. So in ADC, the 0 volt is represented by 8 zeros, correct? And the max limit, that is the 5 volt, it is represented by all ones. That is 11111111 in that way. And intermediate, the step size, we have seen yesterday the formula for the same. So depending on your V reference, these step size are going to be depends. Whether in 0 to 5 volt, at 1 volt it has to step out, or at zero point 0.5 volt it has to step out. So that step size is depends on the V reference. So these few parameters are very important while designing such type of the constructions. Now, as far as the DAC is concerned, that is opposite one, that is digital to analog converter. So as we have seen in the last session that in the types, it depends on the way of conversion. So basically two ways are there by which the digital signal can be converted into the analog one. That is, we are giving the input as 11111111, and it will gives the in form of the 0 1 2 3 in that way, point 0.1 0.2 or point not not 1 in that way, because the analog signal is a continuous signal. So in that way it is going to be depends, but it has some disadvantage. That is the first method. So commonly used is the R2R ladder type of the DAC are mostly been preferred. So what is this R2R? So that is a part of homework for you if you want. But here we have to concentrate on the interfacing of this one of the DAC, that is 0808 with 8051. So this is the pinout diagram. I hope all of you has drawn yesterday. So 16 pin IC. So it has the A1 to A8. 8 inputs, that is digital input. Pin number 4 is configured as a IO, that is output current. So DAC is giving the output in terms of current and not the voltage, which is a normal case in every devices and we have seen till now. So this current we have to convert into the voltage. So how to convert the current into the voltage? Yes, can anyone? So these basics you might be studied in your NTA or ECAD subject. How this current, voltage and resistance, the relation, and how you can convert, and from current how you will get the voltage. Okay, so that we will see ahead at what the method they have used for converting of this one. Pin number 13 VCC, pin number 2 ground. VEE, so that is the negative voltage it is required for the working of the internal component. The V reference. So here also the concept of V reference plus and V reference minus, it comes to just decide the step size. The compensation, again, it is used for the setting of the resolution or the respective particular the noise which is going to be added while the conversion is going on. So for that, the compensate k plus minus 1 volt or a zero point 0.1 volt accuracy is getting adjusted. So for that decision, this compensation terminal it is given. But for normal use, this terminal it is no, cannot be used or may not be used. Pin number 1, so that is the no connections. So in the same way, the pin number 16 is also of no connection, we can say in other way. So this is what the pinout diagram yesterday we have seen. And after that, the interfacing, also two diagrams we have already seen. So in this, if I will just move between these two diagrams, so you can observe the port 1 is connected as an input for DAC. Port 1 is acting as an input for DAC, digital input. But here, one thing we are supposed to observe key P1.7, it is connected to D7. P1.0, it is connected to D0. And here, if you are looking for P1.0, it is connected to pin number 12. So what is the pin number 12? So that you're supposed to just check out. It is A8. It is A8. Means 1.0, it is connected to pin number 8. And in this diagram, P1.0, it is connected to D0. So that various or different construction or the design you can observe in the different diagrams. But which is more correct? So when we will see the actual simulation, so that time we will come to know की ह्याची पहिली टर्मिनल ह्याच्या पहिल्या टर्मिनलला कनेक्ट केलेली इथं ह्या डायग्राम मध्ये ह्याची 8051 ची पहिली टर्मिनल ह्याच्या 8व्या टर्मिनलला म्हणजे MSB ला कनेक्ट केलेली आहे. सो विच इज करेक्ट, कारण ते जर कनेक्शन उलटे सुलटे झाले तर सो द आउटपुट इज ऑल्सो नॉट गेटिंग ॲज पर एक्सपेक्टेशन. So in this way also we supposed to just check out the different diagrams. After that, in this diagram 4 number pin ला output है, 4 number pin ला output है. So if you are looking here, so pin number 4, it is output current it is giving, and that is converted into the voltage by inserting one resistor across the it, and so that across this 2.5k we will get the voltage, respective analog voltage. So this is the simplest way they have shown in this particular diagram. Got it? Here pin number 3, which is pin number 3, that is VEE. So it is connected to the minus 12 volt. Here also it is connected to minus 12 volt. So in this diagram, the value of C they have not provided. The resistors values here they have given provided this one, but here this value of C is not provided. So in this diagram they have provided this particular value. So which value we have to choose? So again, that is a part of a design. Got it? So we have to just, because yesterday only I told that okay, just I am doing work on that only. So which value has to work? So trial and error I have did, but actually there is a design part behind that. So from the data sheet you supposed to check out की तुम्हाला आउटपुट व्होल्टेज किती पाहिजे, स्टेप साइज किती पाहिजे, मग व्ही रेफरन्स त्याला किती घेतला पाहिजे की जेणेकरून ऍक्च्युअली डीएसी तो सस्टेन करू शकेल. कारण सिम्युलेशन मध्ये तुम्ही काही घेऊ शकता, it will give the as per your expectation or not, that is the way. But when you're directly going for a physical practical, so that time it may not work. कारण जर चुकून तुम्ही जर जास्त व्होल्टेज दिलं किंवा जास्त करंट त्यातून व्हायला तर तो आयसी किंवा तो डिव्हाइस डॅमेज होऊ शकतो. So for that the trial and error it is required at the primary level. And if you have gone through the detailed design, so definitely की 500 पिको घ्यायचा का 100 पिको फॅरेड वाला कॅपॅसिटर घ्यायचा, so that you can decide. But here as the this simulation part is going on, or the for educational our purpose, so it is okay to just make a trial and error and you can construct the this circuit diagram in Proteus. The next point I want to just discuss that here, if you are looking for pin number 4, that is output, they have used the external this circuitry additional, that is using the op-amp. In this diagram no op-amp they have used. Got it? Directly one resistor it is been connected and output is taken out. But in this diagram they have added the some external circuitry, and the reason for that also yesterday we had discussed that I to V converter. In this earlier diagram only one resistor has did that work, but in this diagram for more accuracy they got this particular the output over here by using the op-amp. So what is this 741? You might be knowing better than me. Got it? Is it disconnected? The connection. Hello, am I audible? Students?
Yes, sir.
Ah, okay. Because in mobile it got disconnected. Just 1 second. Failed to join meeting. Why such message is coming? Okay, let us continue. So here the different circuits use the different techniques and different methodology to just get the to achieve the output. So here they have used the IC741. So some other ICs are also available. So that also can be used. So that we will see at the time of the actual simulation. If you are looking at the left side, so that is the normal by default the connections are required. That is the crystal for supporting to that C1, C2. It is a 1 microfarad, 1 microfarad. So that is the connection. So here the reset, that is the pin number 9 of 8051. So it has been connected in a such a manner. So it is a switch so that if it is closed, the total circuit will be get reset. So that is a common part, not related to the DAC conversion. Plus here the V reference plus minus. So it is the actually V reference minus, it is directly can be connected to ground, and V reference it should be or it can be more than the VCC. If you are taking the VCC 5 volt, so you're supposed to take this is the double for getting the step size, more step size, so that we will get the identification ki, this is the what it is going to be happen. So this is what the diagrams explanation. So now we will go with that the exactly the simulation one. So here the one of the program I have just copied. So that is the assembly code for generation of the square wave. So normally the application of DAC is for the generation of waveform, that is digital to analog conversion. So if discrete values are given, so it is converting into the square wave, triangular wave, sine wave, staircase wave, and in that way. So this is what the main application of the DAC, and in that regard only one of the application, that is the square wave generation code, it is written over here. So if you can see this code in front of you, so you just go through it. That as normal, it is starting with the 00H, then port P1, it is initialized with 00H. So why 00H? That now you are habitual of that. 00 means it is working as a output port, is it? Because here, if you are looking, the digital in this digital input, it is going as a digital output. It is going for this particular digital input of this 0808. So it is working as a output, that I want to say. So this is what the 00 it has been configured. Then the call square wave 1 subroutine, it is written this much part only, 1 2 3 4 4 lines code is, it is sufficient over here to get that the respective output to us. So square wave 1, so that is again jump repeat, means this is the continuous square wave. We don't want that the only one uh, cycle of the square wave, so that's why it is continuation, it has been written over here. So this is how the code it is going to be work. So what is this written in this subroutine? Subroutine मध्ये काय लिहिलंय की स्क्वेअर वेव्ह म्हणजे काय असतं, 1 आणि 0, इज इट? सो पोर्ट P1 ला आता FF लोड केलेलं आहे. FF लोड केलं म्हणजे 11111111 म्हणजे लॉजिक 1. आफ्टर दॅट कॉल डिले 2 सेकंद, म्हणजे 2 सेकंद साठी हा इथे एक डिले लिहिलेला आहे, ते 2 सेकंद थांबणार. पुन्हा P1 इट इज एंटर्ड बाय 00 म्हणजे 0 लेवल, परत 2 सेकंद थांबायचं, परत रिटर्न बॅक. सो दिस इज हाऊ इट इज गोइंग टू बी वर्क. म्हणजे 101010 इन दॅट वे इट इज गोइंग टू बी वर्क अँड वी विल गेट द स्क्वेअर वेव्ह. आता डिले 2 सेकंद असं त्याचं नाव दिलेलं आहे. तर हा जो प्रोग्राम आहे डिलेचा, सो डेफिनेटली इट विल बी फॉर 2 सेकंद. सो कसा काय हा 2 सेकंद साठी आहे, तर इफ यू आर रिमेंबरिंग द लॉजिक विच वी हॅव नोटेड डाऊन दॅट टाइम, की मी हा स्टँडर्ड डिलेचा प्रोग्राम असं सांगितलं की 1 मिली सेकंद साठी. So that time you might be observed. So this is the 250 हे 500 वेळा रिपीट होतं. मग त्यासाठी लागणारा टाइम 2 मायक्रोसेकंद आहे. मग ते 500 गुणिले 10 that microsecond it is going to be done the multiplication, and this is additional, that is 20 times it is going to happen. So 2 second. So in this way this is the delay program for 2 second. So in that way also you can just remember this one, because somewhere or in exam if it is been asked ki write a program, delay program subroutine for 2 second, so your answer will be like this one. So this is what the additional delay program is here, the green lines. So this is the program for the square wave. Now actually we will go and see how the simulation is going to be done, and I have gone for the triangular wave generation. की डिजिटल इनपुट दिल्यानंतर त्याचं ट्रायंग्युलर वेव्ह मध्ये कसं कन्व्हर्जन केलं जातं. सो फॉर दॅट द कोड इज डिफरंट अँड द सिम्युलेशन द डायग्राम विल बी द सेम. फक्त हा जो कोड आहे, कारण हेक्स फाईल आपण त्याला ऍड करतो, सो दिस प्रोग्राम इज ओनली गोइंग टू बी चेंज. So now we will move towards that the simulation part. So for that first we supposed to open the kill, and you can see here it directly gets open because in the morning only I have opened it. So this is what the program is in front of you. So zoom is not here, so you can zoom from your screen and you can read the program for the triangular wave generation. This is the program for triangular wave generation. So it is started with the 0 0 initialization. But here, if you are observing, move P2 comma 00H, that is port P2, it is configured as a output, because whatever the Proteus diagram, so this is the what diagram is there. So here P2, this port I have used for the connection. So that's why the P2 is initialized as a output port. Then call try-wave, म्हणजे हा सब रुटीन लिहिलेला आहे एक ट्रायवेव्हचा, तो कॉल केलेला आहे. तो कुठे आहे, तर इथून इथपर्यंत तो कॉल करतोय आणि जम्प रिपीट, म्हणजे एवढे एक्झिक्युशन झाले की पुन्हा एकदा तेच, पुन्हा एकदा तेच. सो इट इज कंटिन्युअसली जस्ट फॉर्मिंग द triangular wave. So what is written in this tri wave? So here it has been taken one of the resistor R7, त्याच्यामध्ये 00 इन्सर्ट केलेला आहे आणि ते 00 P2 पोर्टला मूव्ह केलेला आहे. P2 पोर्ट, कारण ह्या पोर्टला इथून इनपुट काहीतरी मिळालं पाहिजे ना, मग त्या प्रोग्राम मधनं ह्या P2 पोर्टला इनपुट मिळतंय आणि इन दॅट वे इट इज गोइंग टू बी वर्क ॲज अ आउटपुट पोर्ट. मग 00 P2 मध्ये गेलेले. त्यानंतर INC R7, म्हणजे R7 हा इन्क्रिमेंट 1 न केलेला आहे आणि जोपर्यंत दॅट इज कम्पेअर अँड जम्प इफ नॉट इक्वल टू FF, जोपर्यंत FF पर्यंत जात नाही तो, कारण 0 0 0 1 1 0 1 1. सो इन दॅट वे until the FF it will reach, it will continue with tri wave 1. Tri wave 1 म्हणजे इथं. So this part is going to be work from 0 0 to FF. व्हॅल्यू यूज तोपर्यंत हे कंटिन्यू राहत जाणार, एक एक न व्हॅल्यू वाढत जाणार. बर, आता म्हणजे 0 टू FF पर्यंत पोहोचलाय, म्हणजे 0 लेवल टू पिक लेवल पोचलेलं आहे. ट्रायंग्युलर वेव्ह डोळ्यासमोर आणा. त्यानंतर वरून खालीपर्यंत अगेन डिक्रिमेंट इट शुड बी. त्यानंतर मग काय केलंय, मूव R7 FFH. आता R7 ला व्हॅल्यू दिली FF आणि ती व्हॅल्यू P2 मध्ये पुन्हा इन्सर्ट केलेली आहे अँड आफ्टरवर्ड्स एक एक न डिक्रिमेंट केलेलं आहे बाय युझिंग दिस कमांड DJNZ, डिक्रिमेंट अँड जम्प इफ नॉट 0. डिक्रिमेंट अँड जम्प इफ नॉट 0 म्हणजे डिक्रिमेंट कर R7 आणि जर 0 नाही आलं तर कुठे जा, ट्राय वेव्ह 2 म्हणजे इथं. म्हणजे हा जो पार्ट आहे तो कंटिन्युएशन मध्ये राहणार कधीपर्यंत, तर जोपर्यंत R7 ची व्हॅल्यू 0 होत नाही तोपर्यंत. दॅट मीन्स द अप्पर एंड टू लोअर एंड, असं ट्रायंगलचं दुसरा एंड आपल्याला इथं मिळालेलं आहे. अँड आफ्टर दॅट द रिटर्न. सो इट इज जस्ट गोइंग टू बी रिपीट दिस प्रोसेस ऑन ऑफ. तसंच ट्रायंग्युलरची एक साइड दुसरी साइड, एक साइड दुसरी साइड, इन दॅट वे. अँड दिस इज द एंड. So this is the simple program for the generation of this particular triangular wave. So I have saved this program. I have checked for the syntax error. So 0 error it has given. So now hex file it has to create. I think it get hang in between. So I supposed to just close it and open it once again. Or already the file is there, so I will take that one file. Got it? So this hex file we need for this Proteus simulation. So just now see the what this diagram, because it looks a very big diagram and complicated diagram, but it is required. Few of the components are not required, but still I have included for the more clarification in this diagram. So what are the mandatory components in this diagram? So this 8051. After that, this DAC 0808. This is mandatory. And this the external circuitry which we have seen. So LF 351. This is what the op amp it is used for converting the current into the voltage. And this voltage it is been shown on the this oscilloscope. वेवफॉर्म आपण तयार करतोय ना ट्रँग्युलर वेवफॉर्म. सो इट इज प्रोव्हाइडेड ऑन दिस पर्टिक्युलर ऑसिलोस्कोप. तर एवढेच कॉम्पोनंट हे मॅन्डेटरी आहेत. प्लस पॉवर सप्लाय द ग्राउंड. सो दॅट इज बाय डिफॉल्ट इट विल कम देअर. अँड ॲज पर द डिझाईन सो वी हॅव टेकन द व्ही रेफरन्स as a 10 volt. V reference as a 10 volt. VEE as a minus 15 volt. VEE minus 15 volt. So, and this one is the 5 volt which is required for the this driving the 8051. So the additional these voltmeters are been connected to just check out की कसं स्टेप बाय स्टेप व्होल्टेज चेंज होत जात आहे. वाढत 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 जाते परत कमी 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 होत जात आहे. फॉर दॅट लुकिंग दिस द ॲडिशनल voltmeters are been connected. So no need of this one to connect over here, but that is required. The other these resistors are just converting the current into the voltage. So for that sake it has been connected over here. No additional any important work for that. So V compensation. So V compensation is also connected to the V reference, or that not V reference, it is VEE. So negative minus 15 volt, it has been connected. That is the compensation pin. V reference, it is connected directly to the ground. V reference minus and V reference plus, it is provided to the 10 volt. So this is the simple circuitry you supposed to build. And this is what the all the components I have set for the 5K, this capacitor. So for getting the exactly triangular shape waveform. So let us save this diagram, then add the hex file. So provide the path for that. Say okay and start the debugging. So when you start the debug, it is taking time to this. And I will run the simulation. So this is what you can observe here. That is the simulation has been started. So again you can make a little bit zoom and just check out the how the inputs are coming to the this 8080, and these voltmeters are showing some readings. So the maximum voltage it is going to be passed, that is the minus 15 volt. So it is accordingly goes upper side and then comes lower side. So that you can observe in this particular diagram. That is, it is a triangular waveform. So that's why it is increasing exponentially and coming back the exponentially. So where is the waveform actually? So this oscilloscope you supposed to check for the waveform. So how to check this oscilloscope? So debug, and at the last all the components it is just showing. So here digital oscilloscope, and you can observe here the actually waveform, the triangular, how it is going to be construct. So this is the as we are handling the oscillator. So the same oscillator is here. 4 channels are there. Voltage per division knob is there. Times per division knob is there. So that way you can just rotate and you can control on that the particular oscilloscope also. So for by default condition, this should be the knobs at 1, so that the scaling factor is become 1 for the calculation. So this is the red one. So red channel we supposed to just check out. So This is what amplitude increase. Scaling factor I am just changing. So at 1, normally we supposed to keep all the knobs this, so that the scaling factor will be the 1. So this is how the triangular wave we can generate by using the this particular DAC. Here you can observe 0 1 1 0 0 1 1. So it is a quick process because the delay it has been given for only 2 seconds. So within that it is going to be go for the next stage. So this is what the simple simulation, but it has taken the 1 to 2 hours to just construct the diagram, because that after the proper selection of this components only we are getting the exact this type of the waveform. So this is what it is needed to be give concentration and accurately we're supposed to make the connections. Even one connection is a wrong one, so it affects on the next what we are expecting. So with this, the next one we will go. The different codes are there with us. So we will go for the staircase. So how the staircase waveform is look like, you might be knowing. You have studied the different subjects related to this. So staircase waveform can we construct? So let us see. So for that the process is the code we supposed to just change. So instead of tri-wave, we will add the code for staircase. So this code it is already available. So I have just copied. I have not written, frankly, just telling. So, but we should have to this knowledge of writing this type of the code, or at least whatever the codes are available. So how they are written and what is the meaning of that, at least it should be known to us, and that I got. So you also has to read these all codes whenever I am just trying to tell. So you cannot adapt at the same time, but afterwards when you are just watching the videos, so listen carefully ki which instruction is for what, the highlighted colors I have given, so which part is for what purpose it is there. So by that only you can understand the logic, and accordingly you will see here. But as it is getting hang, so I supposed to close this and open this. So just give the 1 minute. Okay, it opened now. So we will copy the code for staircase, and I will just replace this the triangular wave by that the. So this is the additional delay routine is there. Delete is been required, and the program is in front of you now. One, if you have given the attention for all this, so this is what I have replaced the triangular code by staircase code. So you have to read the code or see the code properly, not read, see the code properly, and you supposed to tell it is given the error. So what is this error? And in the chat box I am expecting from you that key, if you have given the attention, definitely you can identify it is a very common mistake. It is there. Mistake means the intentional I made that there, so that you can find it over here. So just try to find out that particular error so that we can fix this particular error and we will get the exact output. So find it out and put in the chat box. Take 2 minute time. Hello. No one has written nothing in the chat box. Why? There is no any logical or technical error is there. Only the logical, I think we can say for that. So what the subroutine we have written for, and here what is it been called? That is the thing, because we have written the code for the staircase. So it's supposed to call subroutine of that one. That is the change in this one. So this should be replaced call triwave instead of call staircase. That is the only, it is the thing due to which we got the error. Got it? So now I will make it, but here zero error now it is showing. So let us see, is it work or not? Because I also not work on this staircase. So let us compile that, getting the hex file. Once the hex file is created, we're supposed to go to the Proteus. Again, that the same hex file we supposed to take it as an input and run here. That is debug start and then debug run. But I think it is not showing anything, but here something we will see. And where is the oscilloscope? So here you can observe the red line on the oscilloscope. Due to the delay, again it goes up. So to see the proper whatever we have seen the, or we know the concept of staircase, so the time division we will just make it. So for staircase, it is not exactly giving the staircase, but steps it is taking, but not the exactly square steps it is taking. Some charging and discharging like this of capacitor it is been taking. But if you can see from the longer view, so here you can observe it goes upper, again come back, goes upward and again come to the lower. That is the step by step. It is steps. It is showing. So the steps we can observe over here, but the shape of the step, so that it is the not exactly square wave, because in this square wave generation also the same thing is happening. So it is needed to work on this simulation particularly ki where is it goes wrong. कारण एक्झॅक्टली स्टेअरकेस मध्ये पण स्क्वेअर वेव्ह सारखीच असते ना, इफ यू आर रिमेंबरिंग, but it is just getting the decrement exponentially. So what is the reason? In the code there is no issue. In the diagram only, the value of capacitor and value of resistor, so that is to be identified in proper manner. So that design part is there. So we have to work on that, the design part, and once I will get that what exactly the error was there, so definitely I will tell. But by that time you supposed to just study this diagram exactly. You can just get repeat the video of this session, and if those who are having the laptops or the computers with you, you can also construct this type of diagram. How much time it is just taking, just check it out. In the study material I will provide the diagram as well as the component list also, because the main part in this, that is the searching for the component. Because if even though you are needed of a register, so what is to be right in that search, so that is also very important. So voltmeter you need, but which voltmeter, analog or digital? Is it a passive or active? So many options are there, so which is to be choose? So that is also again the same point over there comes. So that all I have given in that supporting documents, so you can follow that and you can use that for your reference. And the relation between this particular k vcc किती घ्यायचं, v reference किती घ्यायचं, ve किती घ्यायचं, that is a design part here. For interfacing it is not that much important, so we are not concentrating on that the that part, because I am also just doing that the trial and error, and by following the 2 3 various diagrams or the designs, I am just checking for that. So when I got that the exact solution for that, why this staircase, it is not exactly the look like the staircase, we will just work on that. So here what, how it is going to just check it out. स्टेप्स दिसत आहेत की इथून 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 इथपर्यंत, परंतु एक्झॅक्टली वरची जी लाईन आहे ती सरळ दिसायला पाहिजे, पण ती एक्सपोनेन्शियली दिसते समच्या डिस्चार्जिंग ऑफ द कॅपॅसिटर. सो विच कॅपॅसिटर इट comes in between, so I will check, and by in the next session definitely we will work on this. And plus the next last point from this unit that we are going to study, that is the stepper motor. So the same thing is applicable for that also. You should read that what is stepper motor, what are its types, how it works. Got it? Because the DAC ADC हे conceptual आहेत की ह्याचं रूपांतर त्याच्यात त्याचं ह्याच्यात, परंतु स्टेपर मोटर इज अ वन इन्स्ट्रुमेंट. त्याला आपल्याला 8051 यूज करून ड्राईव्ह करायचंय, म्हणजे रन करायचंय. मग ते कसं वर्क होतं, त्याला काय काय पॅरामीटर्स आहेत काय नाहीत, सो दॅट इज एक्सपेक्टेड फ्रॉम यू टू स्टडी first, so that whatever we are going to learn over here, that is the here what the point they have included ki interfacing of stepper motor. But what is stepper motor that they are not expecting to give over here, but still we will go through that how it works and the types of that. But from your end also it is expected to just work on the this particular point फॉर द स्टेपर मोटर, की कुठल्या कुठल्या मोटर असतात, मग ते एसी मोटर आहे का डीसी मोटर आहे, मग त्यात काय आतमध्ये काय काय असतं, स्टेटर असतं, रोटर असतं, वाइंडिंग असतं, मग हे काय असतं. तर हे बेसिक इलेक्ट्रिकल जो तुम्हाला फर्स्ट इयरला आय थिंक सब्जेक्ट झालेला आहे, सो इन दॅट यू माइट बी गॉन थ्रू विथ सच टाइप ऑफ द instructions or these particular types of the motors, that is AC motor म्हणजे काय, DC motor म्हणजे काय, and how it works. So definitely a little work it is required on such point. So I think today is the Thursday, so our lecture is on the Monday only. So you got the Sunday time. So on that day, just go through that, or those who have gone through already, so no issue with them. But those who have not studied, so for them it is a homework that you supposed to just check the stepper motor, because without getting some basic knowledge of that, you cannot understand anything from the next session. So that is expected from you. Definitely we will start with this DSC only, that this part is remain ki he staircase dakhwate, parantu exact it is not as per the expectation. So what is that problem? That I will work on this. Okay, so I think this is okay for today's session. I hope the logic at least you got from this one. And in the next session, we will work on this one again morely. So now you can just put your attendance in the chat box. Don't forget to put your attendance, and you can leave and stop sharing. If any doubts are here, just ask me here only. Rutuja Yadav, are you there? Just put the attendance and leave the session if you are there.